The tool that we use to configure, build, download, and debug operating system images is called Platform Builder. This is the integrated development environment that we use to build Windows CE.NET operating system images. Let's get started. So the way that we build a Windows CE operating system image is through a set of wizards. This is started by using the File menu. I select File, and then New Platform. This brings up the Platform wizard. This will ask me a number of questions about the platform that I'm going to be building. To start, I simply hit Next. You can see that I have a number of BSPs, or board support packages, listed within the Platform wizard. Right now, I have support for x86, sh4, and the ARM series of processors installed. This list is extensible. I can plug in additional board support packages as required. For today's lab, I'm going to be using the ICOP Vortex x86 reference board. Interestingly, I could multi-select at this point in the wizard. So I could select both the emulator and the Vortex x86 board, or I could select the CEPC, or in fact any number of the BSPs that are shown in this list. The advantage here, of course, is that I could start working with one board, and then as another board becomes available, I can then switch to using that board instead. I'm simply going to hit Next. And this will then start asking me questions about the type of platform that I want to build. You can see that I have a number of available configurations listed here. And this ranges from residential gateway, which is a headless device, a device that doesn't use a mouse, a keyboard, or any kind of video hardware. Or I could start with something like the tiny kernel, which would just be the kernel and file system, which would be approximately 300 KB in size. If none of these configurations match the needs that I have for the platform I'm building, I have a couple of options. I could start with tiny kernel, which will just give me the kernel and file system, and then I could make use of the catalog, which we see on the right-hand side of the screen here, and pull out components from the catalog and add these to my workspace. Alternatively, I could select custom configuration in the wizard, and this will step me through a series of 19 wizard pages asking me various questions about the platform that I'm going to be building. In this case, I'm going to choose Internet Appliance, and I'm going to call this platform a demo. You can see that this platform is going to be created in a folder WinCE420 public a demo. We'll have a look at the folder structure used by Windows CE later in this demonstration. Okay, so I'm going to move on and hit Next. And now the wizard will start asking me questions that are specific to the type of platform that I'm going to be building. Because we're building an internet appliance, obviously an internet appliance device, it's going to be using some kind of screen, maybe a mouse and keyboard, or alternatively a touch screen. If I was going to be building a headless device like a residential gateway, obviously I won't be asked questions about user interface applications, applications like the internet browser, applications like the file viewers, and so on. For the platform we're building, we don't need the .NET Compact framework. We don't need Windows Media Support, but perhaps we do want to make use of the Internet browser. In this case, we're going to be using the Internet Browser 6.0. I hit Next, and now I get asked about networking and communications. One thing to bear in mind about this wizard is that the wizard will just give you a starting point configuration for your platform. Let's say that we get to the end of the wizard and our workspace is created for us, and at this point we decide that actually we really did need to have the .NET Compact framework. That's not an issue. We can simply go to the catalog, locate the .NET Compact framework component, and then add that back into our workspace. So the wizard gives us a baseline configuration for our platform. In addition to adding additional components from the catalog, you may find that the wizard gives you a component that perhaps you didn't need. Maybe you included the .NET Compact framework, but then at the end of using the wizard, you decide that actually you don't need that in your final configuration. You can then go to your platform workspace and remove the .NET Compact framework from your platform workspace. So it's very flexible. In this case, you can see that for local area network, we have both wired and wireless connections. For personal area network, we have technologies such as Bluetooth and infrared. We also have support for wide area networking, dial-up and PPTP. In this case, I'm just going to hit Next, and then the wizard is complete. At this point, I can just hit Finish, and this is going to create my platform workspace for me. Once the workspace is complete, we'll then go ahead and start configuring the operating system image that we're going to be using. So on the right-hand side of the screen now, we have the catalog of components. In the center of the screen, we have a workspace that we would use for either writing source, for a driver, or for an application, or browsing some of the source code that ships with Windows CE, or alternatively setting breakpoints either in the source that ships with Windows CE or in my own source code for an application or a device driver or a DLL. On the left-hand side of the screen now, here's our platform workspace. You can see this is called a demo, and when I expand out a demo, you can see that I have a couple of nodes being displayed here. At the top, I have the BSP, or the hardware-dependent features of my platform. I can expand this out, and you can see that I have various device drivers listed here. So this is hardware-dependent. I also have a section here which is called Internet Appliance. This is the platform-independent components that are listed out of the catalog or have been pulled out of the catalog. Earlier in this presentation, I mentioned that I could use more than one BSP when I'm creating a platform. So I could have emulator, I could have the Vortex x86, or I could have an ARM, a MIPS, or an SH platform being used here. The great thing about the platform wizard is that because it creates both a platform-dependent and platform-independent set of components, when I'm building a platform for x86, MIPS, ARM, or SH, the set of operating system components that I've chosen are actually going to stay consistent across each one of the platforms that I'm using. So I simply need to select Build and choose whether I'm building for x86, MIPS, SH, or ARM, and just target the output for the specific BSP that I'm using. If I expand out the Internet Appliance, you can see the various technology components out of the catalog listed here. Right now, we're building a release image of the operating system. One of the things that we want to show you as part of this presentation is how you debug the operating system. So of course, what we need to do is change this from being a release build of the operating system to being a debug build of the operating system. Okay, now that we've done this, let's go ahead and add a couple of applications into our platform. The way that we add applications or DLLs, and a DLL of course could be a device driver, it could be a DLL that simply exports functions or exports resources. Resources are particularly useful if you're building multilingual user interface applications because you can store all of your locale information in a separate DLL. So what I'm going to do now is select File, select New Project or File, and this is going to start the project wizard. This is going to be asking me some questions about the type of project I'm going to be building. You can see that I have a number of options here. Windows CE application, and that's what we're going to be choosing. Windows CE console application, obviously this is just going to be having text output onto the screen. Windows CE dynamic link library, and so on. In the case of the Windows CE application, the application that we're going to be building is going to be a C or C++ Win32 application. This can be a fairly basic application, but this requires you to call the native Win32 APIs inside of the operating system. For more advanced applications, you may consider using technologies such as MFC, the Microsoft Foundation classes, or ATL, the Active Template Libraries. Both of these technologies are exposed through a separate program which is called Embedded Visual C. This ships with the Windows CE product or can be downloaded from the Microsoft website. If you're thinking of writing managed code applications, using languages such as C# or Visual Basic.NET, that's the domain of Visual Studio.NET 2003. So you'll need that product to write managed applications for Windows CE. Okay, so in this case, I'm going to give my project a name of KevLab, and this is going to be short for Kernel Event Viewer Lab, and I'm going to click on OK. As part of the wizard, you can see that I have three options. An empty project, of course, this just gives me a project workspace without any files. I could choose a simple Windows CE application. In effect, what this is going to do is create my main source files for me and give me an entry point for my application, which is called WinMain, the entry point for all Windows applications. And from that point forward, I need to write all the code for the application myself. Or I could choose a typical Hello World application. And in this case, all the code for the application is going to get written for me. This is going to be pretty fully featured. It's going to have support for drawing on the client area of the screen, creating the initial window that's displayed to the user, and handling a number of messages that are delivered to the application by the operating system. In our case, we're going to choose an empty project. The reason why we're choosing an empty project is because the source code we're going to be using for this application has been pre-written. In this situation, perhaps this is going to be an application that I've used in a previous operating system image, and I simply want to move the code over into this new project. So I'm going to click Finish. And one of the things you'll notice change within Platform Builder is the view that we have on the left-hand side of the screen. So previously we had a feature view, which is the standard view for the operating system, which gives us the view of the hardware independent components, and now a new folder which is called User Features. And this shows our new application, kevlab.pbp, or Platform Builder Project, has been added into the workspace. Parameter view I'll come back to in a moment, but you can see that we have a new tab being displayed, which is Class View. Class View gives us a view onto our applications, showing us the classes and also the member variables that are exposed out of our applications. An alternative view onto the application would be the file view. And for KevLab, you can see that there are no header files, no resource files or source files. Let's go ahead and add these from our hard drive. So I'm going to select Project, Insert, Files, and this is going to add files from the hard drive of my development machine. I'm going to browse to a folder called CE Demo and into a subfolder called KevLab. And this contains all of the source files for our KevLab application. Actually, right now, not all the files are being displayed, so I'm just going to change the files of type to be all files, star.star. And this now shows us all the files. I'm going to select the files and then click on OK. And you'll notice that the file view now changes to show all of the source files that are available as part of the KevLab application. One of the other things that you might have noticed change is that we now have a resource view as well. Obviously, the resource view is going to give me a view onto any of the resources for the application, whether this be menus or bitmaps or whatever other resources we have for this application. Again, if I switch back to the class view and expand this out, you'll notice the globals. So you can see here we have functions for dealing with the about box for the application. We have each of the individual functions exposed out of the application, as well as all of the member variables being exposed out of the application as well. So the KevLab application is now ready for us to use. Of course, we need to build the operating system, and we need to build the application as well. We're not actually done with configuring the operating system image, so let's now go ahead and add a second application. I'm going to select File, and New Project or File. In this case, I'm going to give our project a name of RegApp. And this is going to be an application that reads a specialized registry key from the operating system and displays the contents of that registry key to the user. So what I'm going to do now is click on OK. Again, this will ask us the same question that we had before with KevLab. What type of project do we need? An empty project, a simple Windows CE application, or a typical Hello World application. And that's the option that I'm going to select for our program. I'm going to click on Finish, and of course what this is going to do is generate all the source files needed for our RegApp application, including the source for creating the initial window and handling various Windows messages from the application. Let me show you what I mean by that. Right now we're on the File view. Let me switch over to the Class view and expand the RegApp classes. If I expand globals, you can see that I have the init instance, which will initialize the application, my register class for registering the window class of the application, WinMain, which is the entry point for the application, and WinProc, which is the Windows procedure, or the procedure within the application that handles the Windows messages being sent by the operating system. What I'm going to do is just double click on WinProc, and that'll open up the source code for the application. You can see the WinProc is clearly displayed here. And if I just slide down slightly, you can see the switch statement, which is testing each of the messages that are being sent to the application by the operating system. And the first message that we're going to be handling is case WM_paint, or Windows message paint. And the WM paint message is sent to our application when the client area of the application needs to be redrawn. In this case, all we're going to be drawing is the words Hello World at the top of the screen of our client application. Let's go ahead and add some additional code in here. I've got about 30 lines of source code that I want to drop in. Thankfully, I've already got this stored in a Notepad text file, so I can just come into here and grab the source code. I'll copy this onto the clipboard and then come back to Platform Builder and paste that source code in. Okay, let's take a quick look at what this source code is doing. So we have now a new handler that says case wm create. And the wm create message is a message that is sent by the operating system to the application when the client area window is about to be created. So at this point, I get the option to do anything that I need to do to initialize the application before the first window is displayed to the user. This is a great place for me to load any resources that I need, whether this be strings or bitmaps or menus or whatever else, create any child threads that are needed, any child windows that my application is going to be using. In this case, what I'm doing, you can see that I have an H key, so I'm obviously going to be doing something with the registry here. What I'm doing is opening the registry, and I'm opening a very specific registry key within the operating system. This is going to be H key local machine, software, Microsoft, demo app. This is a key that does not exist as part of the standard Windows CE operating system image. So obviously this key needs to be added to the operating system for us to be able to read it. And we're going to be adding that key in a second. So we're testing the return result from the call to regopenKeyEx. And this could be either a success if the key exists or a failure if the key is not there. And obviously if the key is not part of the operating system, we're going to get a failure. So if we get success, we then query a value within that key, which is going to be the name. And that, in this case, it's going to be my name that I put into the registry. And if we read successfully from the registry, I then throw up a message box, which will put my name up onto the screen. Now, one thing to bear in mind, because we're doing this in the wm create handler of the operating system, the wm create handler is sent to our application before the main client window is displayed to the user. So in this case, we'll see the message box displayed on screen before the main window of the application is displayed. So when I click on OK to cancel the message box, at that point, the main window of the screen will come up afterwards. As I've already mentioned, wm create is a great place for you to create any additional resources or load any resources that you need out of your application before the main client window is displayed. If the registry key is not found, again, we throw up a message box, but in this case, we're putting up a message that's saying, hey, you know what, the name is not found in the registry. So it's going to be very obvious when we run this application whether the registry key is found or not found. Okay, so that's it. That's the sample code that we've added into our RegApp application. And remember, the RegApp application is an application that was created by the new project wizard inside a platform builder. So apart from the wm create handler, everything was written for us as part of that wizard. Okay, so already we've had a look at the class view, the resource view, and file view. And these, of course, all deal with the applications within our platform. We've also seen the feature view. And we know that within the feature view, we have our hardware-dependent components, we have our hardware-independent components, and we also have our applications or projects. And this, of course, could easily just be a DLL or a DLL, which is a device driver. In our case, we've got two applications, one called KevLab and the other one called RegApp. The one view that we've not had a look at so far is the parameter view. Now let's take a look at this. Let's expand this out. And you can see that I have the ICOP Vortex x86 parameters. I have hardware-specific files, which if I expand, you'll notice that I have a number of files here. Some of these files are called .bib or binary image builder files. And this is a listing of the components within the hardware-specific parts of the operating system that will be included in our final operating system image. I have a platform.dat file, and the dat file lists out the folders that need to be created as part of the operating system. I have platform.db, which is database files, and platform.reg, which is the hardware-dependent registry keys for the operating system. Obviously, the key that we want to add to the operating system, which is simply my name, has got nothing to do with hardware. This is a hardware-independent key, so we don't need to touch the hardware-specific files here. What I'm going to do is open out the project-specific files. And you can see here, again, I have a BIB, and this is where I would add additional files into my final operating system image. I also have a project.dat. This is where I'd create any additional files or folders needed for the operating system. Project.db, which is databases, and project.reg. This is the registry or the user accessible part of the registry. This is not hardware dependent. Let me expand out the reg file, double click on that. And you can see some of the registry keys already in place here, including HKey local machine, ident or identity. By default, this is going to be choosing a name of Windows CE and a description Windows CE device. If I want to change the name of the device on the network, then it's this location within the reg file that I need to modify. Let me go to the end of the registry. And you notice this is just human readable text. As part of the build system, this will get converted into a binary image of the registry. But right now, to add or remove or modify registry keys, I can just use either the platform builder or any kind of text editor like Notepad or whatever else. Let me go back to Notepad, and inside of Notepad, I've got the registry keys that I'm going to be using for my application. I'll copy that to the clipboard and then paste that into my registry. You can see here, we've got the registry key, HKey local machine, software, Microsoft, demo app. This is the same registry key that we were going to be reading from our reg app application. And then name, I've got your name goes here. And of course, what I need to do is replace that with my name. One thing to bear in mind when you're adding registry keys, if I was to accidentally leave off one of these double quotes as part of the registry key and rebuild my operating system image, that's going to cause 5 build errors as part of the build process. So if you build the operating system and you see 5 build errors, that's a pretty good indication that you've left off one of the double quotes as part of the build. Okay, so at this point we are pretty much ready to build and deploy the operating system image. Of course, what we're doing here is building a debug image, but one of the final steps of this demo is to run a set of remote tools to examine the underlying operating system and how that's running. So in this case, we need to set up some of the platform settings. Let me hit Platform and Settings. And you can see here that we have a number of options. On the General tab, I can set the build release directory, the build type, and the target file that's going to be generated. For Windows CE, when we build the operating system, we end up with one single output file at the end of the build process. And the output file is called nk.bin or newkernel.bin. And it is this one single file that I download to my target device. This is somewhat different to Windows XP Embedded, where when I build the operating system, I end up with a set of flat files and folders like Documents and Settings and Program Files and Windows and Windows System 32. For Windows CE, the entire operating system is in this one file. This includes the underlying registry. This includes the kernel, our device drivers, our applications, our resources, bitmaps, and audio and video files, and so on. On build options, what I'm going to do is enable event tracking during boot and also enable profiling for the operating system. The reason why we're enabling event tracking during boot is because we want to capture some of the events that occur inside of the operating system, interactions between interrupt handlers, interaction between the underlying kernel of the operating system, and interaction between various applications or processes that are running on top of the operating system. Of course, when I'm booting the operating system, there's a certain point that I can start to run these remote tools, and that's the point that the operating system is fully loaded. Of course, at that point, I may well have missed various events that have occurred inside of the operating system before I had the ability to run the remote tools. So that's why I'm enabling event tracking during boot, so that I can still examine that information even though the remote tool is not running at that time. Okay, I'm going to click on OK. And then at this point, I really am ready to build the operating system. The build process will take approximately 10 minutes to complete, so I'm not going to run the build process as part of this lab. Instead, I've got a pre-built version of exactly the same platform that we've just created, which is running in a separate version of Platform Builder over here. Of course, what I'm going to be doing is downloading my operating system image to a remote target device. In this case, I'm using an ICOP x86 reference board. We need to configure how we talk to that reference board. So before I switch over to the second version of Platform Builder, I'm going to show you how we configure the remote connection between, in this case, the platform A demo and the target device that I'm going to be using. I'm going to select Target and Configure Remote Connection. On the Configure Remote Connection dialog, you can see that I have a number of options. On Download, I can choose either Emulator, Ethernet, or Serial. In our case, we're going to be using Ethernet for both the download and also the debug transports for Windows CE. If I was downloading to the emulation environment, the emulator, at this point I could click Configure, and I can set various properties for the emulator, including the screen width, height, and color depth, or alternatively use a skin file, the amount of memory that's available to the emulation environment, whether I'm using just outgoing networking, and this is great for browsing out to an external internet site, or maybe I have an application that's using technologies like MSMQ or .NET Compact Framework application that's making use of XML web services running on an external server. In all of these cases, my Windows CE device is reaching out to an external server or device. In the situation where I'm running the HTTP web server on top of Windows CE, or maybe I'm hosting an XML web service on top of my Windows CE device, somehow those devices need to be able to get into the emulation environment as if it's a real device on the network. In that case, I would change my Ethernet settings from outgoing only to use virtual switch instead. And virtual switch gives me the ability to also host inbound connections. So on my desktop machine, I could browse using my Internet Explorer to HTTP, the IP address or name of the emulator that I'm running. I also have the ability to use hardware pass-through. In this case, I can make use of the serial ports and parallel ports on my desktop machine. And these would appear as COM1, COM2, and the parallel port inside of the emulation environment. Now, why might this be useful? Well, take the situation where perhaps I have got an external serial GPS device, which is connected to my desktop PC, and I don't yet have a device driver for this for my emulation environment or for my Windows CE device. What I can do is hook this up to the serial port of my PC, maybe serial port 1 or serial port 2, and then have direct desktop pass-through between the Windows CE emulator and that GPS device. So I could be reading GPS coordinates off the GPS sensor directly into the emulation environment without actually needing physical hardware. And obviously the same is true of the parallel port. Okay, I'm going to hit cancel here. Obviously we're not using the emulator in this case. What we're using is Ethernet for download and also Ethernet for the kernel transport. In this case we're using Ethernet to download and debug. You'll notice that I have an additional option down here which is currently disabled, which is use Hardware Debugger. And it tells me that I can select an EXDI driver, and EXDI is the extended debug interface. If I'm using a hardware reference platform that perhaps supports JTAG or BDM, then I can plug in an EXDI driver that supports JTAG or BDM to give me direct hardware interface down to my reference board. In this case, I'm using Ethernet for both download and debug, but how do I figure out which board I'm going to be talking to from Platform Builder? Well, in this case, I hit Configure for the download service, and this brings up a dialog box which will show me any reference boards that are booting onto the network. Let me turn on my reference board, and when the reference board is turned on, it's going to send a boot me request onto the network. When the boot me request is received by Platform Builder, it will show me the name of the device that has just booted onto the network. I can then select that device from the list, and here it is, CEPC RT622, and then click on OK, and then click on OK to close the Configure Remote Connection. At this point, I can select Build and Build Platform. This is going to take about 10 minutes to complete. Once the build is complete, I would then select Target and download and initialize to download the operating system from Platform Builder into the device that I've configured to work with this version of the platform. Okay, so at the moment I'm done with this version, a demo. So I'm going to minimize Platform Builder here, and I'm going to switch back to My Platform. So here is the My Platform workspace. I'll just drag the catalog out of the way for a second. This is configured in exactly the same way as the previous version of Platform Builder that we're using with a demo. What I want to do now, before we download the operating system to our target device, is show you how we locate source code inside of our workspace. Windows CE ships with approximately 2 million lines of source code that we can use to assist with platform bring up and also platform debugging. You notice that I have the ICOP Vortex x86 workspace shown on the left-hand side, the hardware-dependent files. Most BSPs ship in source, So I should be able to browse the source for those directly from the platform workspace. In a number of cases, a silicon vendor or a system integrator may ship their BSP in binary form, in which case you won't have access to source for that. Obviously, the user features, the platform builder projects, KevLab and RegApp, we've got the source for those files because we've created those from the project wizard inside of Windows CE. And then we have Internet Appliance, and this is the portions of the operating system that have been either added to the platform workspace by us directly, or alternatively, portions of the operating system that have been taken from the catalog as part of the platform wizard. So I'm going to expand out Internet Appliance. I'm going to come down to File Systems, Storage Manager, the File System Driver Helper Functions, and open up a file called fsdalloc.cpp. This is how easy it is to locate some of the source that ships with Windows CE. So I'll double click on that file, and this will open up the source code for this file, fsdalloc.cpp. It's now very easy for me to just scroll down this file, locate a line of code that kind of looks interesting, and set a breakpoint on that code. I'm just going to press F9 on the keyboard here, and you can see that this puts a breakpoint into the source. So at this point, I'm ready to download my operating system image. I've already configured the transport for Ethernet, download and debug, and the connection between Platform Builder and the same reference board that we were using just a few moments ago. So what I'm going to do now is select Target and Download. You can see this brings up a security warning asking about Kittle. I'll come back to this in just a second. And now I simply turn on my reference board, and this will download the operating system from Platform Builder to my target device. Okay, let me explain about the Kittle warning that was just displayed. So Kittle, K-I-T-L, stands for the Kernel Independent Transport Layer. And this is the transport that's used for download and debug, and also the use of remote tools and embedded Visual C on top of the platform that we're using. The warning that we had here was that if we enable Kittle, then the Windows CE device may well have access to certain folders on my desktop machine. We've already seen that we have a build release folder, sometimes known as the flat release directory. And the build release folder is the folder that contains all of the files that are used to build the operating system image into the final output file called nk.bin. Now, as far as Platform Builder is concerned, the build release folder is going to be in WinCE 4.2.0, public, name of your platform, which in this case is my platform, reldir, and then I'll have an x86, either debug or release, because we're using an x86 platform. The reason why Kittle throws up the security warning is that when our operating system is fully downloaded to our device, within the file system of the Windows CE device, I'll have a folder which is called release. And that release folder is an exact mirror of the contents of my hard drive build release folder. So any file I drop into that release folder on my desktop machine is then instantly viewable by the Windows CE device. And also the opposite is true as well. Any file that is created by an application running on the Windows CE device in the release folder is then again instantly visible to my desktop machine, which is great for logging. Maybe I have an application or a device driver that creates a .log file in my WAC release folder on my Windows CE device. Without having to power down or use remote tools to upload any files from the CE device, I can just go to my build release folder and use something like Notepad to view the contents of that log file. It makes it extremely easy for me to transfer files up into the Windows CE filing system or extract information from the Windows CE device and view that directly on my desktop. Okay, so we've downloaded the operating system. You can see that we have a number of debug messages being displayed at the bottom of the screen here inside of Platform Builder. We know that we're at a breakpoint because our breakpoint circle has changed from like a pink color to a red color. I also have the current instruction arrow, the yellow arrow, pointing at this line of code. And also on the status bar at the top of Platform Builder, you can see the word break inside of brackets. This, of course, tells me that the operating system is in a break state. So the operating system is halted. I don't have any user interface at this point. Now, this brings up an interesting point about debugging on devices like Pocket PC. For any of you that are interested in debugging things like device drivers, the first point that you've got the ability to connect a debugger to your Windows CE Pocket PC device is when the operating system is fully loaded and you have the shell and user interface being displayed, And at that point, you can connect Active Sync, and then over Active Sync, you can use tools such as Embedded Visual C. Very early in the boot process of Windows CE, the device driver manager, device.exe, is going to get loaded, and the device drivers, of course, will then initialize, and the device drivers can then, of course, run the code that you've written. And this is way before the user interface of your Pocket PC is displayed, and therefore you don't have the opportunity to debug device drivers at the kind of level that we're debugging here with Platform Builder. Okay, so I'm at a breakpoint. One of the things that I'd like to show you at this point is what we can do with the source that we've got. We're using Windows CE to debug, at this point, part of a file system driver. It'll be kind of interesting to find out which device driver is getting loaded at this point. Unfortunately, inside of the code fsd alloc.cpp, I can't find that out. What I need to do is step up a level in the call stack to find out exactly which driver is getting loaded at this point. So I'm going to select View, Debug Windows, and Call Stack. And this shows me the list of functions that have got me to the point in the operating system that I'm at right now. You can see that I'm currently inside of a function called allocfsd. And allocfsd was called by the function fsdload. If I double click on this line, you can see that I now have a green arrow pointing at this line to show me that fsdload is the currently opened function in the call stack. Let me close the call stack. And you can see fsdload is now being displayed, including the current line that we're at, which is calling the function that we broke on, which is called allocfsd. Now, inside of this code, what we'll actually see is a structure called pinitData, and pinitData contains a number of things, including the name of the driver that's getting loaded. What we can do here, we can do a number of things. We could view memory, we could view the current list of running processes, the current list of running modules, or DLLs. In this case, what I'm going to do is simply right-click on pinitData, and then select Quick Watch. And Quick Watch is going to bring up a Quick Watch window. And if I scroll this down, you can see the name of the driver that's getting loaded. And the name of the driver is called relfsd, or the Release File System driver. Funnily enough, this is the driver that is responsible for sharing the build release directory on my desktop machine and the whack release directory inside of the Windows CE operating system image. Okay, let me close that down. And also, we're done with debugging at this point. So let me just select Edit and Breakpoints. And I can remove the breakpoints that we've set. This is the breakpoints dialog that gives me the ability to set additional breakpoints, conditional breakpoints. I can break if memory has changed. I can break on the nth time that we've passed a certain line of source, and so forth. But in this case, I simply want to remove the breakpoint that we've set. So I'm going to hit remove all breakpoints, and then click on OK to close that dialog. And at this point, I'm ready to allow the operating system to finish loading. I'm going to select Debug and Go. And at this point, we should see even more debug messages being displayed in our debug output window. Once the operating system has finished loading, we'll then be able to switch to have a look at the user interface of Windows CE. Now, the way in which we're going to view the user interface of Windows CE is through a remote display control application. The Windows CE image for my platform that I've downloaded has got an additional application included in it that we didn't add to our A-demo image. And this is called CE Remote Display. The component name is CE-RDisp. What I'm now going to do is just run that program on my Windows CE device. And I'm going to put in the name of my desktop machine. And there we have it. So we're now connected to our Windows CE device. So this is great. This gives me the ability to remotely view the contents of my Windows CE device. I can now run applications, I can look at the IP address, and I can do all of this from my desktop machine. Okay, so we added two applications into our platform. We added KevLab, which we'll come back to later, and we also added RegApp, the registry application. Let me open up my computer. You can see the various folders within the Windows CE file system. including the Windows folder, and that's where we're going to go to find our RegApp and KevLab applications, and also the release folder. This is the shared folder that is shared between our platform build release folder, also known as flat release dir, and also our Windows CE device WAC release folder. So any files that I drop into here on my desktop can be seen by the Windows CE device. And any files that are created by my Windows CE device in the WAC release folder can instantly be viewed by my desktop machine. I'm going to open up Windows. You can see by default the Windows folder is only showing folders. It doesn't show me all of the applications and DLLs that ship as part of the Windows CE operating system. What I need to do is click on View and Options and turn off the Hide Protective Operating System Files and Do Not Show Hidden Files and Folders, and then click on OK. By default, any files that are created as part of the operating system are hidden within the Windows folder, so you don't actually get to see these. Of course, you can change the file settings so that your files are not hidden or are not marked as system files. And these are the typical attrib settings that you would set from MS-DOS or a command prompt inside of Windows XP. S for system and H for hidden. Okay, so here's the contents of my Windows folder. If I scroll this down, you can see that I have my RegApp application here. Okay, so what's going to happen when I run this application? Of course, what should happen is the RegApp application should go ahead and read the registry key that we set inside of the operating system and display a message box to us that shows us the contents of that registry key. And we shouldn't see the main window of the application being displayed to us until we dismiss that message box. So I'm going to double click on RegApp. You can see the registry key has been read and my name is being displayed on the message box. And it says name from registry Mike Hall. Behind the message box, you can still see the Windows folder. And obviously that's showing us that within the WM create handler for our application, we haven't actually got as far as showing or displaying the main window of the program. I'm going to click on OK for this message box. And once the message box has been dismissed, you'll see that the main Windows application is now being displayed. Once that's displayed, we can just close down that application. And we can also close down the File Explorer, close down the Windows folder. At this point, we're actually pretty much done with the remote file viewer for Windows CE, so we can minimize that. So at the moment, we've run our RegApp application. We're now also going to run our KevLab application. Let me first explain to you what the KevApp application is doing. It might be useful for us just to pop across and have a look at some of the source for this. So I'm going to close down RegApp, expand KevLab, globals, and then get into WinMain, into WinProc for this program. So what this is actually going to do within WM Create is it's going to call a function called create demo stuff. This is going to create a critical section. We're going to initialize that critical section. We're then going to create 3 child threads. Each of these threads, let me just scroll down to the thread code. Each of these threads is going to try and gain access to that application global critical section by calling a function called enter critical section. Obviously, because this is a critical section, only one thread at a time can gain access to that critical section. Once I've gained access, I'm going to output some CE log data into the kill stream, which can then be viewed by the remote kernel tracker or the kernel event viewer. I'm also going to output a debug message so that within Platform Builder we can see which thread has got access to that critical section. I'm then going to pause for a period of time. I'm going to sleep. And then once I'm done sleeping, I'm then going to leave the critical section. Obviously at that point, the next thread in turn can gain access to that critical section and then can output its CE log data and its debug messages. Okay, so let's go ahead and start the remote kernel tracker. This is on the Tools menu, so I select Tools and Remote Kernel Tracker. That starts the kernel tracker program. This is going to ask me which platform I want to talk to. In my case, I'm going to choose Windows CE.NET default platform and default device. One thing to note here, default device is always the last platform I downloaded to from Platform Builder. So with Platform Builder downloading an operating system image to my Vortex x86 board, I already have an Ethernet download and debug kill connection to that board. So in effect, we're going to piggyback that kill connection for the default device. I click on OK. You can see that we're establishing a connection to the device. We can see some kill debug messages being displayed inside a Platform Builder just behind our remote kernel tracker window. And then once kernel tracker has made its connection, on the left-hand side of the screen within kernel tracker, we should see a list of processes that are currently running on the Windows CE device. Okay, so there we have it. You can see that we have interrupts, we have NK, the kernel, and then I have various processes that are running. FileSys, the file system, device.exe, the device driver manager, GUIs, the graphical windowing and event subsystem, CERDISP, that's our CE remote display, and so on. What is not currently running is our kernel tracker program, KevLab. So let's go ahead and run that. And actually, there are a number of ways in which I could do that. Since we have a shell on this device, I could just go to the Windows folder, locate the KevLab application, and run that. Alternatively, from Platform Builder, what I can do is click on Target and Run Programs. Run Programs is going to enumerate all of the .exe files, all of the processes in my build release folder, and give me the ability to select one of these programs, in this case KevLab, and run that program. Now, one interesting thing to think about here, this is a list of all of the executable programs in my build release folder. That doesn't necessarily mean that the program is part of my nk.bin, part of my final operating system image. So what I can do here is use remote applications such as Embedded Visual C or applications such as Visual Studio.NET 2003 to build an additional application. And then all I need to do is drop that application into my build release folder from Platform Builder and select Target Run, and instantly I can select that application even though it's not part of the operating system image. If it's not part of the operating system image, it will be pushed down to the board and then executed. In our case, kevlab.exe is part of the operating system. So when I select Run, you'll see Run Program, S, Start, KevLab. You'll then start to see some debug messages being displayed inside a Platform Builder, showing you which thread inside of the process has got access to that application global critical section. Okay, let's switch back to the remote kernel tracker. And what we'll now see is that I've got kevlab.exe as a process being displayed in the list of running processes. If I expand that list of processes, you can see that I have kevlab, and then I have 3 child threads. Obviously, every process within Windows CE has at least one thread of execution. That is the main application thread. We also have the 3 child threads here, which were created within the wm-create handler for Windows CE application. Okay, right now we're on a zoom range of 1 millisecond. Let me expand that zoom range up to 10,000 milliseconds. What you can now see is the call for sleep event for each of the threads in turn. So what we can do is zoom in on one of these threads, and hopefully we'll see the interaction between the thread and the underlying process. Okay, let me expand this out slightly. Okay, here we go. This looks like an interesting piece of data to examine. Let me just zoom this even more to 100. And what we can see here is a square with 4 dots in it. And that square with 4 dots in it shows me that I've got a custom CE log event at that point in the data stream. So if I just hover my mouse over that, what you can see here is we now get a data tip being displayed that shows me raw long 3. This is thread number 3 that is currently being activated at this point. And then further along, you can see that we're entering that sleep event. So that's the period of time that that thread is going to be sleeping. Okay, so the other thing to bear in mind here with CE log, the call to CE log data, is that we can output pretty much any additional data into the data stream. With that data tip being displayed, we not only saw that the This was thread number 3 out of our 3 child threads that was running. We also saw that the thread had a current thread priority of 251. Windows CE as an operating system supports 256 levels of thread priority, and by default, all threads in the operating system are created with a thread priority of 251. To change that thread priority, I call one of 2 APIs, either set thread priority, which is a supporting function for older versions of Windows CE, versions of Windows CE version 2 through to 3, 2.12, only supported 8 levels of thread priority. So the call to set thread priority gives me the ability to set, in effect, the lowest 8 thread priorities in the operating system. Alternatively, if I want to make use of all 256 levels of thread priority, I will make a call to CE set thread priority, and that gives me the ability to set a value from 0, which is highest priority, down to 255, which is lowest priority. Okay, so we've seen the interaction between the threads inside of the KevLab application. You can clearly see each thread in turn getting access to the critical section and then sleeping. So we're now done with the remote kernel tracker. I can now close this down. And no, I don't want to save the collected data, but I could save that data and view that later on. Now at this point, of course, my KevLab application is still running. And there are a number of ways in which I could shut that down. For any of the users that have been working with Windows CE since version 2 and onwards, you'll probably be familiar with the CE shell and the CE command prompt. So what I could do here is use commands such as gi proc, get information about running processes, and this will list out all the running processes in the system. I can see that process number 7 is kevlab.exe. So to kill this process, I'll simply type kp kill process 7, and that would kill process number 7, which is kevlab. Alternatively, I could go up to View, Debug Windows, and look at Processes. And again, this gives me a list of running processes inside of the operating system, one of which is going to be kevlab.exe. If I select kevlab, I can then select the kill button, and that will stop the kevlab application. And you'll notice that the debug windows will then, the debug messages will then stop. Okay, so at this point, we're pretty much done with the demo, and we've covered a huge amount of ground as part of this 1 hour. We've not only shown how to configure the Windows CE operating system image using both the platform wizard as well as the application wizard, but also on top of that, we've also included information about how to add additional code into your application, how to configure the operating system image using the catalog, how to add in additional registry keys using the parameter view within the Platform Builder IDE, how to configure the remote connection between Platform Builder and your target device, how to download the operating system to the target device, how to locate Windows CE kernel source inside of your platform workspace, and also set breakpoints within that source, how to debug. In our case, we set a debug breakpoint inside of some of the source code for the file system driver code. And we then used the call stack. We then examined some of the data for one of the variables, pinit data, which showed us the name of the current driver being loaded. We also examined how to remove breakpoints within the operating system, how to allow the operating system to continue debugging from a break state, how to run applications using the Windows CE user interface, and also how to run applications using the Platform Builder integrated development environment. We also made use of some of the remote tools, in this case Kernel Tracker, to examine the interaction between threads and processes inside of Windows CE. Hopefully, this was a useful demo for you and has given you a great starting point for working with Windows CE. Thanks for watching.